So this is 3.1 limits. This is part 3 from our handouts from class. So we're going to be starting the examples from the book. And this says use the properties of limits to help decide whether each limit exists, and if it exists, find the value. You can verify it with your calculator, but on the test you will have to show your work. At any time you need to pause, go back, pull out a handout with your rules, please do that. So we have 3 examples that I pulled from the textbook to kind of go over the idea of what do we do if when we plug it in we get 0 over 0 form. That tells you you have to factor to cancel. So again, I'm going to just do that to just make it a little bit easier on myself for my limit. So it's difference of squares on the top. In the denominator, it factors to x plus 3, x minus 2. So the x plus 3's cancel. I have the limit as x approaches 3 of x minus 3 over x minus 2. This again means that there is a hole in the graph that was able to be canceled. It's still a rational function that we're dealing with here, but we can now plug in for my value that I have, and it's a limit as x approaches a negative 3. So now I'm going to plug in the negative 3. Gives me negative 3 minus 3 on the top, negative 3 minus 2 on the bottom, which ends up with a negative 6 over a negative 5. So my final answer there is 6/5. One mistake with a sign will mess this whole problem up. Going to number 38. This is a little bit hard to see the way that they have it written, so I'm going to first rewrite it so you're clear on what we have. So we have the limit as x approaches 0. This is negative 1 over x plus 2 plus 1/2. So this is actually even a complex fraction, but if I plug in 0, I'm actually going to get a half plus a negative half on top, which gives me 0 over 0. So remember, to simplify this one, I'm not canceling. I actually am going to get rid of the complex fraction portion. So I'm going to multiply by the LCD to build the LCD. So this would be multiply the first one by 2 over 2, second one by x plus 2 over x plus 2. So I end up with negative 2 times x plus 2, and x plus 2 over 2x plus 2 in the numerator. So I can collect like terms there. In this case, you can notice that the negative 2 and the positive 2 will cancel when I add them together. So I'll be left with x over 2 times x plus 2. Now I'm going to flip that denominator piece, because remember this is an actual fraction, so this is x times, divided by 2x plus 2 times the reciprocal of the x, so times 1 over x. So now these x's will cancel, leaves me with the limit as x approaches 0 of 1 over 2 times x plus 2. Now I can substitute in finally. Gives me 1 over 2 times 2, which is 1/4. So complex fractions still play a part in here. This is why we said we needed to make sure we had those down. The last one from this grouping is a problem where if I plug it in the way it is, I'm going to have to deal with the 0 in the denominator here. So first thing I'm going to do is FOIL this piece out. This, remember, means x plus h, x plus h, x plus h. I'm going to leave that portion for you to actually FOIL that whole piece out. When you do FOIL that whole piece out, you will get x cubed plus 3xh squared plus x squared h plus h cubed minus x cubed all over h. This is from that minus x. What I would have done was take x squared, x plus h times x plus h, gives me x squared plus 2xh plus h squared, and then multiply again by x plus h. That's how I got those first terms. You can't just, it's not x cubed plus h cubed. That's really important. So now you can see that these will cancel. And it leaves me with 3xh squared plus 3x squared h plus h cubed all over h. Now every single term in the numerator has an h in it, so I can cancel that h from the denominator for every term. So I'm left with 3xh plus 3x squared plus h squared. Now I can plug in my 0 for my final step, and so this will give me 3x times 0, 3x squared plus 0. Those are gone. 3x squared. So in general, when you are asked to find a limit, your first step absolutely should be plug in and simplify if it's possible. If you get 0 over 0, that probably suggests you need to simplify first and then plug in. Either factoring, get rid of a complex fraction. You saw all three formats here. If you can't do either of those two, look at the graph in your calculator and go from there. Draw the graph, though, on your paper. I do not want you to do the graph if you can do the first or the second. If you can do the first or second, I want it algebraic. So we're going to go back and do another piecewise function, and remember I've told you that you're going to have to do one of these by hand on the test. You're going to have to draw it, and you're going to have to answer questions from 3.1 and 3.2. So remember how we did this the last time? We actually broke the graph into different pieces. So for the first piece, it's g of x is equal to 5, and that's when x is less than 0. So when x is less than 0, it doesn't matter what I plug in, but 0 is going to be my open, so make sure you write that. And I'm less than 0, so -1, -2. It's always going to be 5. So I'm going to go and plot those. So 1, 2, 3, 4, 5. It'll be open here, and it's a constant. So that's my first graph. Second graph, g of x is equal to x squared minus 2, and that's if I am in between but including 0 and 3. So this is closed, this is closed, so plugging in 0 I get a -2, and I'm going to change my color here so you can see it when I graph. This would give me 1 minus 2, which is -1, 4 minus 2, which is 2, 9 minus 2, which is 7. So 0, -2. I have a closed. 1, -1. 2, 2. And 3, and that's closed. And you should know that this should have a parabola shape. But make sure you're clear that those are closed. Going to the third piece, we have y equals 7 when x is greater than 3. So this one here, I need to do my boundary at 3, 4, 5, and this is going to be open. So it's 7 every spot. So even though this one is open, it's still closed in the red portion, so we still include it. So there's my graph. If your graph is wrong, you cannot answer the questions. So now looking at A. A says, what is my limit as x approaches 0? As x approaches 0 from the left, it is approaching 5. As x is approaching 0 from the right, it's approaching -2. So that does not exist. If I asked you to explain why, you would say the limit as x approaches 0 from the negative is 5, and as it approaches it from the right, it is -2. For B, B has you looking at x equals 3, and as we approach x equals 3 on the red, and we approach x equals 3 on the green, we are approaching the same value, so it's equal to 7. One more for this portion. We're going to look at one that we can't simplify, so we're going to have to graph this. There's nothing we can cancel for this. We can't plug in. So this is in the form, if I were to try to do it, I would have gotten a -6/0 if I would have plugged it in. So we're going to graph it. And you can again also put it into your calculator, but there is a asymptote at x equals 4. And we have this rough shape when you look in your calculator. So when we look at this piece, we are going down and we are going down. And so they match. So my limit as x approaches 4 of f of x is equal to a -infinity. That's what I want to see on your paper. Why did you decide that? You can't plug it in, so you're graphing it to show that. That's how you prove it.